What is going on, guys? My name is Amos and I'm back again with another video. So we are exhausting these properties like there is no tomorrow. So in today's video we want to talk about the for or operator and the existential operator and how we can come up with propositions with these two operators. All right, so this extends what we talked about when we were talking about negation, conjunctions, disjunctions, equivalence, implication. So this is going to be an extension to that. So I've actually introduced two more operations that we can have. So we'll start with the for or operator. All right. So we'll start with the for or operator. So now, whenever you want to say that any element that you take from a certain set, maybe you want to check it. If you have let's say you have it's going to be easier to explain with an example. All right. Now let's give ourselves some predicate. Remember, this is going to depend on n, so it's going to be a predicate. Let's give ourselves some predicate. So let's have 2n minus 4. All right, strictly bigger than 0. This is going to be our proposition. All right. Now, what does for all? All right, for all n in the set of, maybe let's start with n. For all small values n taken from this big N. All right, so I'm actually going to, if let's say we have for every n in P, and let me just write this. So this is a proposition. We've constructed a proposition. Now, is this proposition true or is it false? How are we going to establish that? So this is a proposition. This that you are seeing here is a proposition. But the question is this true or is this false? Well, whenever we employ this for or operator, whenever we use this for or operator, all natural numbers, for this to be true, all the natural numbers that we consider have to satisfy the proposition P. If there is at least one proposition, if there is at least one value of n that is not going to satisfy this P of n, then the entire proposition for every n in n, Pn is going to be false. It is only true when all values of n taken from the set of natural numbers, in this case, are going to satisfy this proposition. Now, I'll tell you that this is going to be false. Why is it false? Well, if you take 1, for instance, 1 is in the set of natural numbers. Now, if you substitute your 1 here, 2 multiplied by 1 is what? 2 multiplied by 1 is 2. Minus 4, we get something that is negative, and we'll get minus 2. Now, minus 2 is less than 0. Minus 2 is not greater than 0. So this is false. Hence, this proposition is false because all natural numbers have to satisfy this proposition. How about if I change my writing? I say for all values of n, now n has to be strictly greater than or equal to 2 in the set of natural numbers Pn. What can we say about this? Well, this is going to be true. Why? Because, well, this is going to be false again. This is going to be false. Why is it going to be false? Because here we have that this has to be strictly greater than 0. When we take 2 as our option, when we take 2, for example, this is false, not true. This is false. Because when we take 2 here, we'll have 0. And 0 is not strictly less than 0. 0 is equal to 0. So we don't have that equality. So this is going to be false as well. But if I say n has to be strictly greater than 2, n has to be strictly greater than 2, well, we have this proposition is going to be true. This proposition is going to be true because we are now going to start at 3. And from 3 going forward, we're going to have positive numbers. All right. So this is only true if values of n taken from a certain from a particular set of numbers all satisfy the proposition P of n. All right. Now let's talk about the existential operator. All right, the existential operator. So if I say, so you can read this as quel que soit And then this one, you can read it as il existe. Il existe, or pour tout, il existe. This one is il existe. This one is quel que soit. So, il existe x dans n, such that p of n. So for this one, if there is at least one x, if there is at least one n, let me just use n, or we can use x just to make ourselves comfortable with everything. So, il existe n dans n. Il existe x dans n. Then we have p of n here. So is this true or false? Well, it is true if we can find at least one number, or if we can find at least one element in the set of natural numbers that satisfies the property 2x minus 4 greater than 0. If we can find such a number, if we can find at least one, then this is going to be true. Now, remember that 1 does not satisfy this proposition that we have here. Okay, it is 2, it is 3, 4. Those are the numbers that satisfy this proposition here. All right. Now, because those numbers exist, we can find some number, at least one number from n that satisfies this proposition. This is going to make this true. So this is going to be true. So that is your il existe. Now, one thing I want to talk about is how you negate such a proposition. How do you negate such a proposition? So what is the negation of quel que soit x in n, and then we have, for example, the proposition p? Well, the negation of this is going to be il existe. So where you have this, where you have the for all operator, you put il existe. So il existe x dans n, and then you have here non p. So this is going to be the negation. Thank you guys for watching, and I'll see you in the next video.